हेलो फ्रेंड्स, वेलकम टू माय चैनल। आज हम डिस्कस करेंगे फंक्शन ऑफ बाउंडेड वेरिएशन का कुछ इम्पोर्टेंट प्रॉपर्टी, रिजल्ट एंड CSIR नेट में आए हुए कुछ क्वेश्चन जो कि मोस्ट इम्पॉर्टेंट टॉपिक ऑफ रियल एनालिसिस इन CSIR नेट। Property 1 says that monotone function is of bounded variation always, but bounded variation does not imply monotone function. Example is given. Of property 2 says that if f close interval ab to r, then the two function given x to the power alpha sin c by x to the power beta, x not equal to 0 and 0 x equal to 0. In two cases, fx are of bounded variation if and only if alpha greater than beta, and not of bounded variation if alpha less than equal to beta. Property 3 says that Lipschitz function always bounded variation, but bounded variation does not imply Lipschitz function. Example are given. Property 4 says that if f is of bounded variation, then f has at most countable number of discontinuity. And property 5 says that if f is function of bounded variation on closed interval AC and closed interval CB, then f is of bounded variation on closed interval AB. Property 6 says that continuous function does not imply bounded function and bounded function does not imply continuous function. Two examples are given here. Property 7 says that uniform continuous function does not imply bounded function. Example is given. And option property 8 says that f is a bounded variation imply f is bounded. And property 9 is f close interval ab to r, f dash exists and bounded, then f is of bounded variation. Property 10 says that if f is periodic plus constant imply f is of bounded variation. And property 11, Jordan decomposition function, says that let f is of bounded variation if it can be expressed as difference of two monotone increasing function. Example is given. Now we will discuss the previous year question of CSIR net in topic of bounded variation, function of bounded variation. One is given, let fx equal to x sin 1 by x, x belongs to open 0 close on interval and 0 if x equal to 0, and gx equal to x fx. Then which of the following is true? Here fx equal to x sin 1 by x, x belongs to open 0 close interval 1 and 0 if x equal to 0, and gx is equal to x fx, then gx equal to x square sin 1 by x, and x belongs to open 0 close on and 0 if x equal to 0. Use the result. In this case x to the power alpha 1 by c by x to the power beta, then alpha greater than beta, then it is a bounded variation. We use this result. Using this result, we see that here alpha and beta are equal, here alpha greater than beta, then gx is of bounded variation but fx is not of bounded variation. Option B and C is correct. Answer B and C. Second question says that f close interval minus 1 on tends to r be a function given by fx equal to x square cos 1 by x, x not equal to 0 and 0 if x equal to 0. Then f is a bounded variation, f dash is a bounded variation, and mod f dash x less than equal to 1, and option 4 is mod f dash x less than equal to 3. We check the options. Here we use the result if fx equal to x to the power alpha cos 1 by x to the power beta x not equal to 0 and 0 if x equal to 0 is of bounded variation if alpha greater than beta. Here we see that alpha is 2 and beta is 1. Then in this case alpha equal to 2 and beta equal to 1. Then alpha greater than beta. So f is a bounded variation. So option A is correct. We check f dash x. F dash x equal to fx equal to x square cos 1 by x. Then f dash x equal to 2x cos 1 by x plus x square minus sin 1 by x into minus 1 by x square, that is equal to 2x cos 1 by x minus sin 1 by x. Then option B says that f dash is a bounded variation. It is not possible because here alpha equal to 1 and beta equal to 1 in this case. So it is not of bounded variation. So option 2 is incorrect. Then f dash x, mod f dash x equal to mod of 2x cos 1 by x minus sin 1 by x less than equal to 2 mod x mod cos 1 by x plus mod sin 1 by x. Here given that x belongs to minus 1 to 1. So mod x less than equal to 1 less than equal to 2 into 1 plus 1 less than equal to 3. So mod f dash x less than equal to 3. So option 4 is correct. So answer is option 1 and 4. Then the question 3 says that which of the following are of bounded variation? X square plus x plus 1 for x belongs to minus 1 to 1, tan pi x by 2 for x belongs to minus 1 to 1, and sin x by 2 for x belongs to minus pi to pi, and root over 1 minus x square for x belongs to minus 1 to 1. Take first option 1. Fx equal to x square plus x plus 1. In this case f dash x equal to 2x plus 1. So in this is greater than 0 when x belongs to minus half to 1 minus 1. Dash x less than equal to 0 when x belongs to minus 1 to minus half, and greater than 0 if x belongs to minus half to 1. So in this case fx is monotone decreasing, and in this case fx is monotone increasing. We know that monotone function is bounded variation is of, in this case is of bounded variation fx. In this case also fx is bounded. We know the result if f is of bounded variation on closed interval AC and closed interval CB, then f is of bounded variation on closed interval AB. Using this result we have to show that fx is of bounded variation in minus 1 comma 1. So it is correct. limit x tends to 1, tan pi x by 2 equal to infinity, tan pi by 2 equal to infinity, it is not bounded. We know that if f is of bounded variation, then f must be bounded. So it is not of bounded variation. So it is incorrect. We check option 3. Here given fx equal to sin x by 2. We know that Lipschitz function is always of bounded variation. We check that fx is Lipschitz function. F of x1 minus f of x2 equal to sin x1 by 2 minus sin x2 by 2 equal to mod of 2 cos x1 plus x2 by 4 sin x1 minus x2 by 4 less than equal to 2 into cos x less than equal to 1, we know that, and sin x less than equal to x mod of sin x1 minus x2 by 4. This is less than equal to half x1 minus x2. fx1 minus fx2 less than equal to k into mod x1 minus x2. So fx is Lipschitz function. Imply fx is of bounded variation. So option 3 is also correct. And option 4 is a monotone function. So monotone function is always of bounded variation. So option 4 is also correct. So answer is 1, 3 and 4. 1, 3 and 4. If you like my video content, then please give me a like, share with your friend and subscribe my channel. Thank you.